The IPCC 6 assessment had a good table of extreme weather events. Every single category of extreme weather events is now documented as increasing. And even, as you mentioned, Regina, the compound extreme weather events, they call them compound co-current. So we have heat waves and then we have floods practically occurring together, and in some cases, actually occurring together.
Hello, everyone, and welcome to another Climate Emergency Forum. Today, we're going to discuss extreme weather and compounding catastrophes. So we have a lot to discuss today, as we seem to every week. So I want to thank you for joining us, and buckle up, everyone, because the storm's barreling down Hurricane Alley. Now, with that, I want to talk about Beryl. As you know, it reached a Category 5 hurricane, and when it landed in Houston, it was less than a Category 1. So this was not a severe hurricane, but what we're talking about is compounding catastrophes. That is, when this happens, that happens. When this happens, this is most likely for that to happen. There were a lot of island states that were hit and horribly affected by Beryl. I feel very sorry, and my thoughts go out to those people who suffered the tragic losses that they did suffer. My thoughts, as always, also go out to the ocean and the probably hundreds of thousands of tons of debris and chemicals and all types of waste that is now added to the trash dump that we call our oceans. It's a very sad thing to see. But in regards to compounding catastrophes, why was Beryl such a huge storm for Houston? A lot of these things that we see are not just the weather, but also related to infrastructure. So I'll speak to the infrastructure of Houston, having been born and raised in that town. One of the things that Houston prides itself in is freedom, right? The freedom to develop how, where, and when it sees fit, with the least amount of regulations. Zoning is considered verboten. While there is a certain degree of zoning, it's really frowned upon in the city of Houston. So with that, there is a tremendous amount of land that has been paved over. One of the phrases that they use to describe Houston is the Bayou City. There are several bayous, very large bodies of water that traverse the city that haven't been paved over. Of course, it's quite close to the Gulf of Mexico. It's somewhat marshy land, if you will. And when you build over this type of land, which was originally meant to absorb rainwater, you prevent that absorption, and it just runs off. It just runs off and it goes everywhere without control. Now, after Harvey, Houston did some degree of mitigation. I believe that they have included some bioswales in various parts of the city so that the water can be absorbed naturally rather than just run off of concrete, from every Walmart parking lot in town. But it's not enough. It's not enough. And this is why we have a less than Category 1 storm devastate the fourth largest city in the United States. Now, also in terms of infrastructure, the energy grid of the city, they pride themselves on being independent. CenterPoint manages the energy for Houston, and in many ways, it has let the citizens of the city down. And as many of you have heard, people have been without electricity for days. Horror stories, really, of people who rely on electricity for their very lives, for oxygen, dying because there's no oxygen, there's no electricity so that they can have oxygen pumped into their lungs so they can survive it. So it's so incredibly terrifying. These are not the things that you think to see in the United States, but these are the things that we do see and we will continue to see. One of the things I really loved about Houston growing up There were a lot of oak trees, just gorgeous trees. And these were nice because they were beautiful to look at, but also they had a really a cooling effect. Now, I visited the city after Harvey, and one of the parks that was the pride and joy of the city, Memorial Park, I used to run there when I was in grad school. Beautiful, beautiful trees. Well, I went there after Harvey. There were next to no trees. It was hot. It was unbearable. There was no way I was going to consider jogging or even walking. I just wanted to get the heck out of there. And now with this most recent storm, Beryl, we have even more trees that have been downed and are dead. So this will set up the environment for more severe storms in the future, compounding the difficulties of climate change. And with that, I want to turn it over to my colleague, Dr. Peter Carter.
Thanks, Regina. Yeah, that was very, very descriptive following your experiences there. It struck me recently, it should have struck me long ago, that what we are calling climate change, climate disruption, and of course, extreme weather events, it's essentially an issue of children, actually, right? Of course, we've been seeing the media, particularly in the States, like every day I go to the news, there's a different distribution of heat waves. There's a new range of severe storms coming through, tornadoes included. And of course, we're focused on the now. But with respect to climate disruption, we really should keep in our minds, foremost and uppermost, that this is an issue of today's children, all the children in the world, because they're going to experience rapidly increasing, worsening extreme weather events, which will be incomparably worse than even what we're seeing today. So I'm trying to do that. I'm trying to focus on children. This year, 24, is going to be certainly comparable with the huge, shocking, surprising degree of increasing global warming in last year, 23. The Washington Post, actually, which I like, Washington Post is very good. They're still putting out maps for where the heat is most extreme. And they're doing this every day. They're doing it for the US and they're doing it globally as well. So thank you. That's a great service. So they pointed out that this year, 24, the start of this year up to June, this is the hottest start to a year ever, hotter even than the extraordinary 2023. I get intensely frustrated every time I read a climate scientist refer to 1.5 because they fall over themselves saying, well, it's not really 1.5, not 1.5 until it's 1.5 to 10 or 20 years. They should be thinking about the children in their life when they're spouting that rubbish, right? We've had 12 months, an average of 1.64, according to Copernicus. 12 months of 1.6 and plus. I think most people are probably aware that we've had over a year, 13 months now with June being at 1.5 degrees C, 13 months of record consecutive months. And we've now had 1.5 degrees C and more for 12 months, month after month after month after month. Children are definitely going to experience what Antonio Guterres, our UN Secretary General, properly termed a hellish future of extreme weather events. And reading the reports on extreme weather events, I think we will all have noticed it's very rare that the reporters, I'm not being too down on them, but it's very rare that they link climate change, global warming with the extreme weather events. And that also applies to the scientific papers, although there was one noticeable exception. The new executive director of the World Meteorological Organization recently, in reporting the increase in extreme weather events and their last World State of the Climate report back in March, stated quite properly that these are going to increase so long as we are emitting primarily from fossil fuels. So that's absolutely key, right? So it's not that we're not even emitting less, but we actually have to stop emitting, right? We have to get down to practically zero on fossil fuel emissions in order to slow down climate disruption and slow down the extreme weather events. The IPCC 6 assessment had a good table of extreme weather events. Every single category of extreme weather events is now documented as increasing. And even, as you mentioned, Regina, the compound extreme weather events, they call them compound co-current. So we have heat waves, and then we have floods practically occurring together, and in some cases actually occurring together. And this is happening all over the world. We're seeing these new compound bang, 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 bang on the environment and on the communities more often. The AR6 even mentioned that the semi-disastrous extreme sea levels, which we're getting now, including on the coast of the United States, they're increasing in frequency. So everything's increasing. And already we're seeing a trend towards accelerating increase of extreme weather events. Of course, the models predicted that long ago, particularly on extreme heat waves, that they would not only increase in an accelerating rate, and that's happening. I just want to mention, I try and mention all the time that we hear, global warming, but the Northern Hemisphere is heating up very, very, very fast indeed. So the Northern Hemisphere for June and the past 3 months, the spring months, the Northern Hemisphere was up to 1.8 degrees C of warming. So we're talking about, really, from the point of view of the scientists and all of us that have a little bit of insight and knowledge into it, we're talking about huge temperature increases now, huge. And the Northern Hemisphere temperature increases are also increasing at a very definite accelerating rate. So therefore, we're looking for the future, and we should be thinking about our children inheriting a world, and not only the first generation to come into a climate changed world, their first generation to come into a world which is getting worse. That's never happened before, really, in all of history of humanity. We've always looked forward to a better future for our children and grandchildren. But we've got a big dramatic change now. It's a drastic change. And it's hard to think, I know, but we do have to put all the world's children right foremost in our thinking. So extreme weather events, yeah, they were predicted to get worse. And now they are getting worse, very much worse, in all regions, particularly this year, the United States of America.
That's so true. That is so true, Peter. And you spoke about the compounding problems that we face here in climate change. But I did mention Beryl, how it was less than a Category 1 storm. Very high winds. One of the things that they believe made this storm as bad as it was that it fell on the heels of a derecho, a very powerful derecho that went through that went through Houston in May. So this is another example of we have these a death by 1,000 cuts or death by 1,000 whirlwinds and derechos. Of course, when there's a storm followed by another storm, these places don't have the time or the money to recover until the next storm hits them. Now, it's interesting that you bring up how much destruction is happening in the States. And I think it's good because people need to have their blinders taken off. These types of hardships have been suffered by many countries in the global South where they don't have the money to fortify themselves. They suffer a harsh weather event, and then before they can even recover from that, bam, they're slammed by another. So it really is a compounding factor. And of course, this is something, as you mentioned, that the youth of the world are going to have to suffer through in ways that we can't even imagine. And it really is a disgusting, grave injustice that we're heaping upon them so carelessly. Paul, it's so good to see you. Please weigh in on the subject for us.
Yes, thank you, Regina, and thank you, Peter. So just to elaborate, Regina, on Beryl, these storms are developing very quickly and getting very, very intense very fast. There's been arguments, I've made them myself years ago, that we need new categories for the Saffir-Simpson hurricane scale. We need category 6 and also category 7, I would argue. If we had category 6 with a reasonable division, then we would have already had 5 or 6 storms that fit under that category. And then there's one hurricane or typhoon in the Pacific Ocean, which would have been approaching or even being classified at category 7 if we didn't have the open-ended scale, which ends at category 5 and above, lumps everything above. And we know one of the main causes that's often talked about is huge sea surface temperatures. So global sea surface temperatures have been setting records and are warmer over the last century on average by at least 1 degree Celsius. If you look at the Atlantic and specific bodies of water, the sea surface temperatures are even warmer, especially in the tropics. But that's not the only reason. I think a bigger factor in the strength of these storms is the cooling of the tropopause. So if you consider a storm modeled it as using a Carnot heat engine model, as I discussed in a video about a week or so ago, it's a temperature difference between the sea surface temperature and the temperature of the tropopause. So although the sea surface temperature has gone up 1 degree Celsius, the tropopause temperature, it looks like it's declined 2 to 4 degrees Celsius, somewhere in that range in the last 45 years or so. So because the velocity reached of these storms is proportional to that temperature difference, the power dissipation of a storm is proportional to the cube of the velocity. This increase of temperature contrast between the surface of the ocean and the upper tropopause is a greatly enhanced factor. But nobody talks about the tropopause. That's the first point I want to make. Secondly, Houston, as we know, got nailed. Beryl was just a category 1, but places around the world are getting nailed, and it's not just from hurricanes. So to give an example, Toronto, Ontario's had a lot of rain places in the last month, so the ground's saturated. Just yesterday, so that's July 16th, there were 3 successive thunderstorms that rolled through Toronto, dumping almost 4 inches of rain in about 4 hours. And this 4 inches or 100, I think it was 96 millimeters of rain, or 97 millimeters. So this rain coming down in a very short period of time, of course, it turned the Don Valley Parkway and major road systems in Toronto into the rivers, literally. Water was pouring down steps of city buildings. There was just nowhere for the water to go. And, I think when climate attribution studies are done, they're going to say that the likelihood of this storm occurring was increased by a factor of 5 to 10 times by climate change. I'm sure that they'll say that when they're completed in a few weeks. So, and getting to your point, Peter, James Hansen has a good letter recently where he talks about the huge heat, the huge global temperatures in record-setting territory. So as of June, the numbers for June of this year, going back 13 months, have set global temperature records. These records were largest in the summers, in the Northern Hemisphere summers, and declined, but were still records, but by a smaller margin in the Northern Hemisphere winter. Looking at the chart, it's almost a guarantee that for July and August, that will extend the record to 15 months and will still be in record territory, but there's a hump in September of this year, where we were about 1.7 degrees Celsius above pre-industrial, above the 1880 to 1920 baseline. So it's going to be very difficult. It's an open question as to whether this record will be maintained come September. But then that would have been a 15-month record. It just shows that the El Nino that we've just had, normally it bumps the temperatures up a lot more in the winter than the summer in the Northern Hemisphere. So because the El Nino has been fading and we're more or less neutral, there's a chance that we could have a La Nina develop. So in all likelihood, that temperature record spree will probably end maybe in September, and we might drop down to 1.4 Celsius. But as you said, we've been at least 1.6 Celsius for that amount of time. That takes us back to last year, about April, May. It started, the record setting spree started about April of 2023, and it's continued since then. So of course, with the turbocharged heat of the atmosphere, the hydrological cycle is also turbocharged, and we're seeing that in all the extreme weather events. We haven't mentioned the jet stream, but of course, that's a big root cause of weather patterns being stuck and persistent.
Thank you so much. Paul, I just wanted to follow up with a quick question. You had mentioned the tropopause. Is this the same thing as what I've heard referred to as a troposphere, the layer above the stratosphere?
Yeah, so the Earth, the layers of air are, the weather all happens in the troposphere, which is a lower atmosphere. The temperature is hottest at the surface of the Earth and declines as you go up in the troposphere. And it reaches a point where it reaches a minimum of temperature, a cold point, and then it's unchanging with altitude for a short distance, and that's the tropopause, which is a dividing layer between the troposphere and the stratosphere. Now, also the height of the tropopause beginning, it's about 17 kilometers or so at the equator. It's only about 7 kilometers at the poles. And because of climate change, the level of the troposphere is actually expanding upward. It's increasing about 5 meters or so per year, about 50, 60 meters a decade over the last 3 or 4 decades. So you can think of it as there's more space for these huge storms to become even larger. So it applies, the idea of the temperature difference is very important, not just for tropical storms, but also for thunderstorms. Because we often see the anvil of a cumulonimbus cloud from a thunderstorm, and that anvil that's happening at the layer of the tropopause, where the clouds all spread out. That gives you an indication of a visual indication of the height.
Wow, that's fascinating. I had no idea that so much was going on up there, and I had no idea that like our actions down here are changing the very nature of the area around our planet. I mean, we're not just affecting our planet, we're affecting miles above our planet. It's really a very intense thing to ponder, isn't it?
Also, of course, we had the ozone scare with the ozone hole, and that's mostly in the stratosphere, in the next layer up. The ozone hole, basically, which is repairing somewhat, but not completely. We're not there yet.
Yeah, we're definitely not there yet. It's very, very fascinating. We've talked about this before, but I want to just briefly go over, Paul, you had talked about the Saffir-Simpson and the categories of storms and how we need to increase it from the top level being 5 to going up to 6 and even 7. What are these things that are making stronger hurricanes? I just want to review for our audience. Global warming, of course, which warmer air holds more moisture, and that is providing additional energy for these storms. And as Paul just mentioned, rising sea surface temperatures, which contribute to the intensity of storms. And of course, we see that a lot in the Gulf states because of the rapidly increasing sea surface temperature of the Gulf of Mexico. And then what we're seeing now is the rapid intensification of storms. They become so powerful in such a short period of time. And this is, of course, goes back to what I just mentioned, is the record-breaking rise in global ocean temperatures. So these 3 factors, the warmer air holding more water, the sea surface temperatures, and that rapid intensification. This is like the trifecta for deadly storms on our planet. And I want to switch it back to Peter and hear what other thoughts you may have gathered while you were listening to Paul speak.
Thanks, Regina. The climate scientists, again, are saying that they're surprised. Not only they were surprised and shocked at the degree of the record 2023 global temperature increase, but now they're equally shocked at 2024. I don't think they should be, because of atmospheric carbon dioxide concentration, which is not getting mentioned, which is quite extraordinary. We know that atmospheric carbon dioxide concentration is the highest in at least 14 million years. We know it's increasing at a completely unprecedented rate, a rate faster than the past 40 million years. Now, if those aren't mind-boggling numbers, CO2 has increased now 52%. NOAA put out a very useful, important brief that pointed out that the past 2 years, atmospheric CO2 concentration has increased the fastest ever. So as we are seeing these accelerating global temperatures and extreme weather events, surely the big reason behind that is that we're still pumping out record amounts of carbon dioxide, also a lot of methane, from continuing to burn fossil fuels. You know, I sort of put together a little mantra for myself years ago. We have no future with any fossil fuels. The only future we have is a future with no fossil fuels. And we have known for decades that we can readily replace all fossil fuel energy with renewable energy. And that's just becoming more of an amazing, definite prospect. The three atmospheric greenhouse gas concentrations, they're all accelerating. CO2 is increasing the fastest ever in the past 6 months and in the past year. The rate of what they call growth of CO2 is going up and up and up. Methane, that's increased by a factor of 2.6. So that's continuing to actually increase at a record rate. And we just had a report from the Global Carbon Project, again, on nitrous oxide. Now, nitrous oxide is number 3 on the list of global warming gases, but it contributes to global warming, so it's very, very, very significant. And that's increasing. And the emissions of nitrous oxide are increasing at the worst case scenario and above. And the atmospheric concentration of nitrous oxide is increasing, worst case scenario and above. And by the way, with the June particularly temperature increase, global temperature is increasing at the worst case scenario. Very definitely. I keep on going back and repeating it because I think, oh my God, you know, why isn't anybody saying this? Yeah, global warming, global temperature increase is increasing at and above the worst case scenario. And that's hardly surprising because of the atmospheric CO2 concentration. I just want to end up by saying that there's been, you know, arguments and discussion amongst the scientists, which is great, on actually how fast the global warming is increasing. But the metric of the 1992 climate convention is actually not global warming. They chose a much better scientific metric, atmospheric greenhouse gas concentrations. So today, obviously, we should be following the accelerating increase in global temperature, which is driving all these extreme weather events. But at the same time, and we're not getting this, we should be hearing and getting regular reports on atmospheric greenhouse gas concentration, CO2 equivalent, and if not, just atmospheric CO2 is more than enough to know where we're headed and the rate in which we're headed and the future we're headed for.
Thank you, Peter. Listen, I got to tell you, you have very high hopes for people on network news. And I think it's great. And I wish that we could have them report on the news, but we all know that they're bought and sold. I hate to be a cynic. I mean, it was only recently that they even started using that dreaded word climate change. I mean, I just remember 6 or 7 years ago, they were all shaking in their boots. They were just petrified. You know, if there was a discussion about weather or climate change, they always had two sides, you know, the scientists who like reported the facts and then Chevron representative or something, because, you know, you have to present both sides. Yes, you're absolutely right. At the same time, as crazy as it sounds, I'm at least kind of grateful that they deign to mention the fact of climate change. It's absurd. We shouldn't have to be satisfied with half-truths in lives. Unfortunately, this seems to be the situation. And it's really, really bad. There's so many people to hold to account for this. And I know that like our topic today is compounding climate catastrophes. And I'm going to place the mainstream news in that category because they have been an absolute catastrophe. They have been hand in glove with the fossil fuel industry. They've been terrible apologists. Can you imagine if they had a discussion on whether or not the planet was round, and then they had like a geologist, or I don't know, a planetologist, and then a flat earther? I mean, it just would never happen. But somehow this has been okay, and it's terrifying. Paul, what are your closing thoughts?
Yeah, I just wanted to remind people the warming records that are being set are, we can talk about averages, but the distribution is very distinct in that the northern hemisphere is undergoing a lot more warming in the southern hemisphere. Of course, there's a lot more ocean in the southern hemisphere. The northern hemisphere, particularly at 45 degrees latitude north, has experienced incredible warming, especially since 2010. And of course, that's being attributed to the reduction of sulfur dioxide in maritime shipping fuels and the reduction of air pollution in China. So with fewer aerosol particles, there's less low-level clouds being generated, so there's more solar radiation incident on the Earth, and therefore greatly increased warming, as James Hansen has clearly showed in a number of different papers, and there's been some papers coming out lately to support his work, and I think there'll be a floodgate of papers soon about these very topics. So that's a key thing to remember, and if you look at the population distribution on the planet, that also matches where the record heating is occurring, unfortunately, in the northern hemisphere. Most people, the vast majority of population on the Earth lives in the northern hemisphere. Also, the warming in the tropics is also on a tear. So 45 degrees north, a band around that, also the tropics. And there's also a smaller band of warming at about minus 40, 45 degrees in the southern hemisphere as well. So the distribution of the warming we can explain by the aerosols. So that's important to remember. Also, the concept of weather whiplashing, I think, is very important because, we go with the jet streams getting stuck, that behavior occurring. We can get lots of rainfall in certain regions, which you mentioned has happened in Houston, to saturate the ground before Beryl came along. Also, it's been happening in Toronto and other parts. And when we have this occurring, we're in a mode where basically that region is in the trough of a jet stream where there's unsettled weather, lots of storms coming through, guided by jet streams. But then that can switch. If the jet stream configuration locks and we're under a ridge, and we have heat waves and drought for extended periods of time, which we're also seeing in different parts of the world. So it's very important to kind of take a top-down view. Sometimes we all need to be astronauts and look down on the planet and see what changes are occurring from a large scale. And a good way to do that, there's lots of programs, lots of software and apps. I just want to give a plug in concluding for Climate Reanalyzer. Looking at the daily weather on Climate Reanalyzer. It's a site by the University of Maine. Just Google Climate Reanalyzer. You can get daily maps. If you look at the daily map on sea surface temperature anomaly from January 1st of 2024 to present day, you can see a moderate El Nino fading out into a neutral state. And then you can look at how the sea surface temperatures are changing around the globe as a result of that, and also the global air temperatures. So you can be that astronaut by going to Climate Reanalyzer and just playing around with all of the different resources that are available on that website. It's a great website.
We live in a time of amazing information. Thank you so much for letting us know about that site. And we will put the link in the description so that you can play around with it too. I think it was in our last show, Peter had talked about our world in data. This is a great, great time for someone who wants to learn. You can be your own expert. It's a time of autodidacticism, if you will. So it used to be that you had to pursue a PhD or some type of higher education in order to learn these things. Now it's available to everyone. So I think that's a great gift that the internet has given us. Now, I often have not so great things to say about the internet, but there are wonderful, wonderful things, including us being able to spend time with you during this show. And you are, of course, the reason for our being, the reason for our doing what we do every week. So thank you so kindly for joining us on this show. Please let us know your thoughts. What do you think were some other compounding factors that made the storm in Houston so difficult for that city? What do you think other cities can do to prepare for stronger storms? Meanwhile, we think you've been here for a while. So if you haven't subscribed, please do. Please do. If it's been a few shows, come on, there's something going on between us. Let's make it official. Hit that subscribe button, and we look forward to seeing you next time at the Climate Emergency Forum.